The video discusses the Sun and its various features, as well as the planets in the solar system and how they have changed over time. It highlights the Triassic, Jurassic, and Cretaceous periods, and explains how the Earth's climate and landscape have changed during these times. This video introduces the viewer to the vast and diverse universe, and explains that the Sun is a typical yellow dwarf star. It also discusses the Sun's surface temperature, and how hydrogen fuels thermonuclear reactions. The video then moves on to discuss the star's inner and outer layers, and how helium accounts for a significant portion of the Sun's volume. Finally, it discusses the star's mass and how it accounts for 99.9% of the solar system's mass. The Sun has a complex structure made up of several layers, with the inner radiation zone being the most dense and the outer convection zone being the least dense. Stellar matter in the radiation zone is constantly transformed into luminosity, while the convection zone produces Sun's outermost layer, the corona. The Sun is also surrounded by an atmosphere made up of several layers of intricate structure. The lowermost layer is called the photosphere, and it emits most of the star's visible light. Above the photosphere is a more rarefied area called the chromosphere, which can be observed from Earth at the time of a total solar eclipse. The chromosphere is extremely hot, with the temperature fluctuating between 4,000 Kelvin and 20,000 Kelvin. The uppermost area of the Sun's atmosphere is called the corona, and it consists of giant prominences, emissions, and shocks. The matter making the corona is remarkably rarefied and incredibly hot, with an average temperature of 1 to 2 million Kelvin. The peak temperature is 20 million Kelvin. In 2018, Parker departed from the surface of Earth on its one-way journey to the Sun. The probe had to execute a number of maneuvers to enter the desired orbit by using Venus's gravity. Once in orbit, Parker slowly adjusted its trajectory, drawing ever so closer to the scorching, blazing Sun. It was ready to withstand the star's searing heat. The probe has been designed with a heat shield, and all the equipment has been made with a view to extreme conditions, such as critical temperatures. The Sun creates strong interference in the microwave range around itself, which means that transmitting the data collected by the probe to the Earth is no easy matter. Nevertheless, the probe is carrying on with its mission. By 2024, the distance between the probe and the surface of our star will shrink to become an all-time short just 6.5 million kilometers. Estimates show that when the probe is in its perihelion, its solar shield may heat up to 1,370 degrees Celsius, which is 3 times hotter than Mercury's sunny side and only slightly lower than the melting point of iron. Even now, the probe is whizzing at a speed of 163 kilometers per second in its perihelion, but it will eventually accelerate to 200 kilometers per second. The video describes the different features of Mercury, including its incredibly hot and geologically active surface. It also explains the planet's unusual orbit around the Sun, including its perihelion and aphelion. This video describes the features and surface of Mercury, which is still mysterious to us despite our recent advances in observation equipment. One of the largest features on Mercury is an escarpment called Enterprise Rupees, which is thought to have formed as the planet cooled. There are also a number of escarpments on Mercury, but Enterprise Rupees is the largest. The features of terrain on Mercury are believed to have formed as the planet cooled, as Mercury's interior gave away some of its heat. The video discusses the Venusian surface, which is very different from Earth's. The planet has a metallic core at its center and no magnetic field, which is why the metallic core is more likely than not in a solid state. The planet's lithosphere doesn't form tectonic plates on account of high temperatures and a high viscosity of the rocks. Venus is also peculiar for not having that many large impact craters, which is why its surface is covered by Oort plains that formed from solidified lava. Some features of the relief found here are uniquely Venusian and are not to be found on any other planet in the solar system. The video discusses celestial objects on Venus formed as a result of tectonic processes. The largest elevated feature on Venus, called Aphrodite Terror, is shown on the map. Areas of different height are marked by contrasting colors, and the region that instantly catches our eye is the largest elevated feature on Venus, dubbed Aphrodite Terror. Areas like that may well be considered conditional continents of the planet. The video then moves on to discuss the second largest conditional Venusian continent, Ishtar Terra. It stretches for roughly 8,000 kilometers east to west and approximately 2,500 kilometers north to south. The territory area equals about 8.5 million square kilometers, which makes Ishtar Terra only slightly larger than Australia. The central region of Ishtar Terra is the largest volcanic massif on Venus, Maxwell Montes. They tower 11 kilometers high above the planet's average level and 7 kilometers above the rest of the relief. Around the highest peak in the region is a comparatively flat plateau measuring roughly 200 by 400 kilometers. The difference in height between the highest peak and the rest of the relief is shown. The Triassic period was a time when the Earth's continents were breaking up and the supercontinent Pangaea was slowly splitting into two land masses. The period was relatively dry and hot, and there were many deserts. The area of inland bodies of water decreased, and new evolutionary adaptations occurred due to the changing climate. The Triassic period extends from 252 million years ago to 186 million years ago. The Triassic period was a time when the Earth underwent large-scale tectonic movements, which led to the extinction of many species of animals. Among the creatures that died out during the Triassic period were marine life and land plants. One of the creatures that thrived during the Triassic period was the saurian, which grew in size and numbers. Other important species that flourished during the Triassic period include the dinosaurs, which evolved from ancient archosaurs. However, the Triassic period was also a time of great ecological change, which ultimately led to the extinction of many other species. During the Jurassic period, the supercontinent Pangaea began to break apart, leading to the emergence of several new continents. Some animals and plants that were abundant on one continent would be non-existent on another. The Earth's climate was warm and humid for most of the Jurassic period, but by its end a comparatively short cooling occurred. Great areas on land were covered with tropical forests, and there were both small and large dinosaurs throughout the period. Towards the end of the Jurassic, mammals, reptiles, and arthropods began to evolve. The oceans were richly populated with bivalve mollusks. The apex predators in the marine food chain were various saurians, some of which resembled modern-day creatures. Towards the end of the Jurassic, Ophthalmosaurus, a marine saurian, evolved with a dolphin-like body and an elegant and powerful vertical tail. The Cretaceous period was a time of great change, as the average temperature increased and flowering plants spread throughout the Earth. Mammals continued to evolve and grow more diverse, with some groups becoming more specialized than others. By the end of the period, dinosaurs were almost extinct, and their ecosystem had to adapt to a new, colder era. Nanoxaurus, a small dinosaur related to the Tyrannosaurus rex, was one of the casualties of this extinction event. The Paleogene period was a time of global change, including the extinction of dinosaurs, the arrival of mammals, and the beginning of the Cenozoic era. The duration of this period was 43 million years. The first period in the new era, the Paleogene, began immediately after the disaster that wiped them off and lasted for 43 million years. The Earth's biosphere changed dramatically during this time, with India crossing the ocean and virtually rammed into the south coast of Asia. The Himalayas rose their peaks up to the heavens, and the Antarctic began to grow its vast ice shield. In the first 10 million years, life evolved and produced the dewar, Andrewsarchus, the giant and rigid Indricotherium, and the aquatic Archaeoceti, the prehistoric ancestors of today's whales. Many of these fascinating creatures vanished without a trace, while others evolved to adapt to the changing conditions. The Paleogene was succeeded by the Neogene period, which lasted around 20 million years. It was divided into two unequally long parts, the longer one of which is known as God. The scene in this period was a time of unhurried and consistent cooling, with ice caps on the Earth gradually growing while the climate became cooler.